At first glance, Starship Flight 13 looked like another successful test. The headlines celebrated another giant rocket leaving the launch pad, another splashdown in the ocean, and another step toward Mars. But if you look closer, Flight 13 was something very different. Hidden inside the single mission were breakthroughs that quietly changed SpaceX's roadmap, strengthened NASA's confidence in Artemis, and brought Starship closer than ever to becoming an operational spacecraft instead of an experimental prototype. For the first time, Starship deployed operational Starlink satellites. It restarted Raptor engine in space, it survived its toughest atmospheric reentry yet, and completed its most controlled landing ever. Even Elon Musk hinted that, assuming the data review reveals no major surprises, the next mission could attempt something people have been waiting years to see – a tower catch of the Starship upper stage. This wasn't just Flight 13. It may be remembered as the day the Starship era truly began. For years, Starship has represented the most ambitious engineering project in modern aerospace. Standing over 400 feet tall, powered by 33 Raptor engines on its super heavy booster, and designed to carry more than 100 tons to orbit while being fully reusable, Starship has never been just another rocket. It's the transportation system SpaceX believes can make lunar bases practical, transform satellite deployment, and eventually carry humans to Mars. Getting there, however, has been anything but easy. The first integrated flights ended in spectacular explosions. Later missions survived longer but revealed weaknesses in staging, heat shield performance, engine reliability, and flight control. Every launch solved one problem while exposing another. By early 2026, SpaceX introduced the first version 3 Starship, a larger, more capable vehicle with upgraded Raptor engines, redesigned thermal protection tiles, improved avionics, and structural refinements throughout the spacecraft. The first V3 mission earlier this year showed tremendous promise, but it also reminded engineers that progress in rocketry is never linear. Then came the countdown for Flight 13. On July 16th, with millions watching, everything appeared ready. The countdown reached the final seconds before several Super Heavy engines failed to ignite correctly. Rather than forcing the launch, Starship's automated safety system immediately aborted the mission. For many launch providers, that would have meant weeks or even months of investigation. For SpaceX, it meant replacing hardware, reviewing enormous amounts of data, waiting out unfavorable weather from Tropical Storm Bertha, and preparing to try again. 8 days later, Starship rolled back onto the launch pad. This time, every one of the 33 Raptors ignited exactly as planned. The launch itself was spectacular. Super Heavy thundered away from Starbase with nearly unmatched power, shaking the Texas coastline while climbing through maximum dynamic pressure, one of the most stressful phases of flight. Cameras mounted throughout the vehicle captured detailed imagery of the heat shield and vehicle structure under intense aerodynamic loads, collecting valuable engineering data that previous flights simply couldn't provide. Then came another milestone. At roughly 2.5 minutes after liftoff, Starship separated cleanly from the Super Heavy booster. The booster immediately began its return toward the Gulf of Mexico. Although this mission wasn't attempting another tower catch, engineers were closely evaluating the upgraded landing sequence. The booster completed its boost-back maneuver and descended under controlled burn before splashing into the Gulf. While not every engine performed exactly as planned during the landing burn, the flight still delivered another enormous collection of data for improving future recoveries. But Flight 13 was never really about the booster. The real story was unfolding hundreds of miles above Earth. As Starship coasted through space, it accomplished one of the most important demonstrations of the entire mission. A Raptor engine successfully restarted in orbit. That single event may sound routine, but it represents a capability that future lunar missions absolutely depend on. Without reliable engine relights, spacecraft cannot adjust their orbits, travel efficiently beyond Earth, or perform the precise burns needed for missions to the Moon and eventually Mars. Then came the mission's biggest headline. For the first time in Starship history, the vehicle deployed 20 operational Starlink version 3 satellites. These weren't test masses or demonstration payloads. They were real satellites designed to expand SpaceX's next-generation broadband constellation. Even more importantly, SpaceX established communications with all of them using both radio and laser links before the satellites completed their planned mission profile. That moment fundamentally changes the conversation around Starship. Until now, Starship has primarily been viewed as an experimental vehicle. Flight 13 proved it can begin performing useful commercial work while simultaneously testing new technology. That dramatically improves Starship's business case. Every future launch now has the potential to generate revenue while validating new systems, a combination that few launch vehicles in history have achieved. But perhaps the most nerve-wracking part of the mission was still ahead: reentry. Returning from space has always been Starship's greatest challenge. Spacecraft slam back into Earth's atmosphere at hypersonic speed, surrounded by an envelope of plasma hot enough to melt most conventional materials. Engineers were especially interested in how the redesigned heat shield would behave under higher thermal loads, and whether the upgraded control systems could maintain stability throughout the descent. This time, the spacecraft looked remarkably composed. The iconic belly flop maneuver unfolded almost flawlessly. Large aerodynamic flaps continuously adjusted the vehicle's attitude as it descended through the atmosphere with extraordinary precision. Then, just moments before reaching the ocean, Starship performed its dramatic flip maneuver, reignited its engines, and executed its softest splashdown ever in the Indian Ocean. Unlike several previous flights that ended with structural failures or uncontrolled impacts, Ship 40 remained intact, floating upright while continuing to transmit valuable telemetry long after touchdown. Inside SpaceX Mission Control, the reaction said everything. Years of relentless iteration had produced the most complete Starship mission ever flown. Dan Huat summed up the mood perfectly by calling it Lucky Number 13. And perhaps that nickname will stick. For NASA, every successful Starship mission brings Artemis one step closer to reality. The human landing system depends on Starship's ability to transport astronauts and cargo safely between lunar orbit and the Moon's surface. Demonstrations like orbital engine relights, improved thermal protection, precision vehicle control, and increasingly reliable flight systems all reduce technical risk for future lunar operations. For SpaceX, the implications extend even further. A fully reusable Starship transforms launch economics. Instead of building a rocket, flying it once, and throwing it away, the long-term goal is to inspect it, refuel it, and fly again, much like an airliner. The Super Heavy booster has already demonstrated tower catches on previous missions. Now Elon Musk says that if post-flight analysis confirms everything looks healthy, SpaceX intends to attempt catching the Starship upper stage itself on the very next flight. Think about how extraordinary that would be. The largest spacecraft ever built returning directly into the launch tower's mechanical arms instead of splashing into the ocean. If successful, it would represent another historic leap toward rapid reusability. Of course, significant challenges remain. Orbital propellant transfer is yet to be fully demonstrated at operational scale. Long-duration life support systems still require extensive testing. Heat shield durability across multiple flights must continue improving. And eventually, Every part of this enormous transportation system must operate with airline-like reliability. None of those hurdles disappear because of one successful mission, but the direction of travel is becoming unmistakable. Meanwhile, Starbase continues expanding at breathtaking speed. Production facilities are growing larger. Florida launch infrastructure continues progressing at Kennedy Space Center. More advanced Starship variants are already under construction, while engineers refine future payload systems and prepare for increasingly ambitious missions. This isn't simply a rocket program anymore. It's become an industrial ecosystem. Every launch validates hardware. Every mission strengthens investor confidence. Every success attracts engineers eager to help build the next generation of spacecraft. Flight 13 may ultimately be remembered not because everything went perfectly, but because it demonstrated something even more important. Starship is beginning to transition from experimental technology into operational capability. For years, every Starship launch asked the same question: can this vehicle survive? Flight 13 asked a different question: can Starship begin doing real work while still evolving into the spacecraft SpaceX has always envisioned? For the first time, the answer appears to be yes. As engineers now sift through thousands of gigabytes of telemetry, preparing the next mission and perhaps the first ever attempt to catch Starship itself, one thing is already becoming clear. July 24th, 2026 wasn't simply another launch day. It may become one of those dates historians circle when they tell the story of humanity's expansion beyond Earth. Because the era of Starship as a developmental prototype is slowly coming to an end, and the era of Starship as the backbone of future missions to low Earth orbit, the Moon, and eventually Mars has finally begun. The sky was never the destination. It was only the starting point. Thanks for watching. Please subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your valuable feedback in the comment section. This will help us to improve.